All right, y'all, I want to talk about this basic energy bar chart. We discussed it in class today. It is an example of a version of one of the ones that are in the first ranking task set. I'm specifically referring this to third and fourth period. As I was going through it and as I was thinking about it, I realized that we approached it the wrong way. And yes, by we, I mean I. So I wanted to go over it again and make sure that we all fully understand it. Now, and this was a little bit brought up during fourth period, so let me show this. We're talking about a block is pushed up, is pushed. So push tells us that we have work, whether we have a work, we have a force, okay? So keep that stuff in mind. We know it's being pushed up, so that's going to be something that's positive. We know that we have a rough ramp as well, and that is negative work. We have to keep that in mind. We have to keep in mind that it moves from constant speed. Okay, constant speed is going to mean that there is no change of energy from the beginning to the end. Okay, they're all going to be the same amount of energy. And if you're getting a shadow on your screen, really sorry. Okay, so this means that KE before equals KE after. And because it moves from A to B, and B is up, we know that we have some type of gravitational potential. So let's go ahead and put all of this stuff together. All right, so in the beginning, there was kinetic energy because it was moving. Okay, I'm not going to say, we're just going to say we have, like, say, 6. I don't know how many this is. I can't really tell. 2, 3, 4. Okay, 1, 2, 3. Okay, we have 6 bars here. So we had 6 bars of kinetic energy. The fact that it's at a constant speed says that the velocity in the beginning matches the velocity in the end. And so if our velocities haven't changed, then that means our total amount of kinetic energy hasn't changed. Okay, just a second, I'm moving something over. So boom, that's going to stay right there. All right, so then let's deal with the work issues. So we are pushing it so that it moves up a rough ramp. So we have to add some type of energy into it so that it goes up. I want this to do 3, I guess. Okay, so it is going up it is going up the ramp. That is our positive work. The rough ramp means that's negative work because we're pulling energy out of this. We're just going to say we're just pulling one bit of energy out. So let's refresh where we're at. Our kinetic energy here and here are going to be the same. Okay? No, never mind. Sorry, checking something out. Our kinetic energies at the beginning and the end are going to be the same. So what we have to deal with now is all this work that we added into it. All right? And that work that we added into it will be represented by the gravitational potential energy it has once it actually gets to point B. So note that we have our net work is only 2. If we have 3 positive work and 1 positive work and 1 negative work, we have a net work of 2. So I'm going to come over here, and that's what I'm going to put in as my gravitational potential. Okay, so here is my net work. If you take a look at it, the entire thing is now balanced. Our kinetic energy is the same from beginning to end. We accounted for the push. We accounted for the rough road, and we accounted for the change in position from A to B. So everything that we needed to deal with has been dealt with. This is the correct answer for this problem. Let me know if you have any questions. See y'all tomorrow.